Hey everyone. So let's talk about artificial intelligence. It's everywhere, right? And it's surrounded by this just mountain of hype. But what if I told you that underneath all that noise, pretty much all of the incredible value AI is creating today, it all comes from one single powerful concept? All right, let's get into it. There's a quote from our source material that just cuts right through all that noise. It says, almost all the economic value has been through one type of machine learning, called supervised learning. So forget the sci-fi fantasies for a minute. The real revolution, the engine that's powering the apps you use every single day, is this thing called supervised learning. And that's exactly what we're going to break down right now. So here's the game plan. We're going to cut through the hype, see what learning by example actually means, look at the world it's powering, check out the different tools for different jobs, uncover the secret ingredient that makes it all work, and then wrap up with a pretty big question.
Okay, let's get right to it and slice through that hype. What are we really talking about when we say supervised learning?
It's actually a surprisingly simple idea, I promise. You have an input, we'll just call it X, and you want to teach your computer to produce a very specific output. We'll call that Y. And the supervised part? That just means we give the computer a ton of examples where we already know the correct Y for each X. It just learns the pattern from there.
Let's use a real-world example, say predicting a house price. Your input, X, could be things like the square footage, the number of bedrooms, you get the idea. The output, Y, is the price. So you train the AI by feeding it thousands of home listings where you already know all those features and the final selling price. See? Input to output. Simple as that.
But this simple X to Y thing, it's not just for real estate. It's the foundation for a huge chunk of the modern digital world that, you and I live in every single day. Let's start with online advertising. It's maybe the most lucrative use of it. The input is a bunch of info about an ad and about you, the user. And the output, a simple prediction. Will you click on it or not? Getting that prediction right, well, that's a multi-billion-dollar business. Or how about photo tagging? That's what we call computer vision. You give it an image as the input, and the output is a label, a tag for what's in the picture. That is exactly how your phone knows there's a cat in that photo you just took. Every time you talk to a voice assistant, you're using supervised learning. Your voice clip is the input, and the text that pops up on your screen is the output. It's the exact same logic for translation services. Input a sentence in English, and the AI, which has been trained on millions and millions of examples, outputs the correct sentence in Chinese. And the progress here lately, it's been just staggering. And this is a big one. It's a critical piece of the puzzle for autonomous driving. A car's cameras and its radar sensors are constantly feeding it input data. The AI's job is to then output the precise positions of all the other cars on the road. And this table just lays it all out so perfectly. Take a look. Doesn't matter if we're talking about ads, photos, speech, or self-driving cars. It is all the same fundamental idea, taking some input X and learning to produce a specific output Y. The real genius is just figuring out what your X and Y are for any given problem. Okay, so if the core idea is the same across the board, are all these systems built the same way? Well, not quite. It turns out you need different tools for different jobs. So within this world of supervised learning, engineers use different kinds of neural networks. The three big ones are your standard network, something called a convolutional neural network, or CNN for short, and a recurrent neural network, which people call an RNN. Think of them like specialized power tools. And here's the crucial thing. They specialize. CNNs, they're the visual experts. They're amazing at processing images, which makes them perfect for stuff like photo tagging. RNNs, on the other hand, are masters of sequence. They have a kind of memory, which lets them understand that the order of things matters, and that's absolutely essential for processing data like an audio clip or a sentence in a book.
So what about that standard network we mentioned? Well, it's a great workhorse for more straightforward data, like in our real estate or advertising examples, and for something really complex like autonomous driving, which has to deal with images and other kinds of data. Engineers will often build a custom hybrid network that combines the strengths of all these different types.
So, we've got the concept and we've got the tools, but what's the fuel for this whole engine? The answer, of course, is data. But here's the thing, not all data is created equal. You can basically put data into two big buckets. First, you have structured data. That's the neat and tidy stuff. Think of a giant spreadsheet or a database where every column, like age or price, has a really clear meaning.
Then there's unstructured data, which is, well, it's everything else. Raw audio clips, images, big blocks of text. And historically, this is the stuff that computers have found really, really hard to understand.
And this, right here, is one of the most exciting things that's happened. Thanks to these neural networks, computers are now getting incredibly good at making sense of all that messy, unstructured data. It's why an AI can suddenly see a cat in a photo or understand what you're saying. This ability to interpret the messy, human world of sights and sounds is what makes modern AI feel so, well, so powerful. But check this out. Here's a really fascinating insight from our source. While the media absolutely loves to talk about AIs that can recognize cats, because, it's cool, a huge amount of the actual economic value from AI right now is being created from good old-fashioned structured data. Things like better ad systems and product recommendations are quietly generating billions of dollars just by analyzing giant company databases. Okay, let's bring this all home. We've seen how this one simple concept, supervised learning, is creating absolutely massive change across so many different industries. If you take one thing away, let it be this. Neural networks have completely transformed supervised learning, and by doing that, they're creating tremendous economic value. That's the real story behind this whole AI boom. But this leaves us with one last, kind of provocative question. Our source material points out that the basic ideas here aren't really new. Some of them have been around for decades. So if that's true, why now? What changed? Well, it really boils down to two things happening at once. First, the absolute explosion of data from the internet finally gave these systems the massive number of examples they need to learn from. And second, our computer hardware finally got powerful enough to actually run these incredibly complex networks. It was the perfect storm of massive data and massive power that unlocked these decades-old ideas. Thanks for tuning in.